All right, hi everybody. As we start our next unit, Unit 7, it's going to be lots of exponentials and logs and solving with them. So we're going to go back to a topic we did in Unit 0, which is solving exponential equations. What the rule says is if you have the same base, then you can set the exponents equal and solve. So same base, set the exponents equal and solve. So we'll start with some easier ones, then we'll get to some harder ones. So in this problem, notice that both of these have the same base of 5. So you can set the exponents equal. So 2x is equal to 16. Divide by 2, x is 8. Yes, it is as easy as that. But what happens when they're not the same base? So notice in part B, you have a 3 and a 27. Your goal is to make them the same base. So what you can do to get them to be the same base is I know 27 is the same thing as saying 3 to the third power. Now that I have the same base, I can set the exponents equal. Negative x is equal to 3, which means x is equal to negative 3. Again, you need the same basis. So look at part C. The bases are not the same. So our goal is to get them to the same base, even with a fraction. 125 is the same thing as saying 5 to the third power, and 216 is the same thing as saying 6 to the third power. So that value outside is a 3. So now that we have our bases are the same, 5, 6, set the exponents equal, and x is 3. Same thing in part D. Right now, they are not the same bases. We have one is 6 and one is 1296. So how do we get them to be the same? You can use your calculator to figure it out. This is not one I would expect you to memorize. But 6 to the fourth is 1296. So we're going to say 6 to the fourth, and then you still have that x. Once again, your bases are the same. And once your bases are the same, you set the exponents equal. X squared equals 4x. In a problem like this, it's quadratic, so I would move everything to one side and then factor it. This has a GCF of x, which leaves you with x times x minus 4 equals 0. Set each factor equal to 0. So x is going to be 0 and x is going to be positive 4. Both of them work. You set each factor. Sometimes what will happen is a problem like E. Notice 256 and 64. Sometimes you have to change both numbers to be the same base, not just one, but both numbers. So in this instance, I'm thinking, all right, 64, 256, I think I can get them to both be bases of 4. So I can try my calculator. 4 to the fourth power is 256. So then I'm going to still have that 3x there. 64 is the same thing as saying 4 to the third power, and I still have that x plus 1. Notice how I'm using parentheses around the exponents, okay? Because now that we have the same base, remember that means you can go ahead and set your exponents equal, right? So I can set those two parts equal. So 4 times 3x is 12x. On the right side, I have to distribute 3x plus 3. If you didn't use parentheses, you probably would get 3x plus 1, and that would be wrong. So what I'm going to solve, I'm going to subtract 3x from both sides. So I get 9x equals 3. And I'm going to divide by 9 on the bottom. So 3 over 9 is 1/3. Make sure you divide the correct way. That should be 1/3. I'm going to go ahead and take a look at part F. 3 to the x squared minus 56 equals 9 to the 5x. I'm going to have you go ahead and stop, and I want you to try this problem. All right, welcome back. Hopefully you figured out that they should both be the same base of 3. So this is 3 squared is 9. So I can go ahead and change that. So now that I have the x, the same bases here, right? We've got a 3 and a 3. So now I can go ahead and set my exponents equal to each other. That's going to give me x squared minus 56 equals 10x. It's a quadratic, so I solve by putting everything on one side. And then I'm going to go ahead and try to factor that. So two numbers that multiply to negative 56 and add to negative 10 is negative 4 and positive, it's positive 4 and negative 14. set each factor equal to 0, and I'm going to get x equals 14, and I'm going to get x equals -4. Both of them are your answers because it was a quadratic. Part G says if 11x equals 5, what does 11 to the -2x equal? Well, if I rewrite 11 to the -2x, and I think of it as 11 to the x, and then I put that -2 kind of on the parentheses, notice that for your bases, both of these have 11x and 11x. So since this is 11x equals 5, we know 11x is 5, you can replace the 11x over here with a 5 and say 5 to the -2nd, and that's going to equal 1/25. So that one's kind of manipulating the fact that we know what 11x is. So in that sense, we know what 11 to the -2x is because we can line up the 11x's to each other. Letter H has an exponent rule in it. Right now, the bases are not equal. You need them to be the same. And you might be like, well, how do I get them to be the same? Anytime it equals 1, you can go ahead and say that that is any number to the 0 power. So remember, any number to the 0 power is 1. So now that we've done that, we can go ahead and say the bases are the same. And since the bases are the same, I can set the exponents equal to each other. So 3x minus 1 equals 0. Add 1, divide by 3, and x is a third. Let's take a look at, I'm actually going to change the problem here for I. So because I'm on my iPad, I can actually just write it in white. And we're going to go ahead and change this problem to 3 to the 5 plus 2x equals 1/81. And we're going to go ahead and solve that problem, okay? So I wanted to practice one like this because you might be like, well, the other side is a fraction. Well, that's okay, because we know 3 to the 4th is 81. So since it's 1/81, that's like saying 3 to the -4th. So now we have the same bases. So we've got 3 and 3. So now you can set the exponents equal to each other. So just because one is a fraction does not mean that you can't do it. It just means that the exponent is negative. So I'm going to subtract 5 from both sides. That gives me -9. Divide by 2, and that gives me -9/2. All right, we're going to take a look at one more. If you take a look at J, you might be like, I have 3 bases now, and that's very true. You do have 3 bases right now. You have a 3, an 81, and a 9, and we need them all to be the same, but I bet we can get them all to be 3s. So that's what I would start with. I would go ahead and say 3 to the R times 3 to the what power gives you 81, and that is going to be 3 to the 4th. And then I'm going to put in parentheses 4 minus 4r equals, and 9 is the same thing as saying 3 squared. Now remember your exponent rules. When you multiply, you add exponents. So because these bases are all the same now, so that's good, we've got them all in 3s, now we can go ahead and add our exponents on the left side. We're going to do r plus this is going to equal the 2. Because again, we're multiplying here, and multiplying means you're really adding exponents. So we're going to write that as r plus 4 times 4 minus 4r is equal to 2. And then you're just going to solve this like a normal equation. Combine my like terms. Move my 16 over, divide by negative 15. A negative over a negative is a positive, so R is 14 over 15. So some of them you might need to use your exponent rules. So remember, when you're multiplying, that means adding. When you're dividing, you would subtract the exponents. Okay, so that's a lot of really good practice. The other type of problem that you're going to see in the notes are word problems, and actually these show up on the final a lot. The nice thing is they give you the equation, so it's not hard. If you had to write the equation, it would make it hard. So let's take a look at example 2. It says, in a single pane of glass obliterates 10% of the light passing through it. Then the percent P of the light, so that's important information, percent P of the light that passes through n successive panes is given approximately by the following equation. So it's very important that they have told you what your variables are. So we know, first of all, that P is going to be your percent of light that passes through, and N is the successive panes. Even if you're not sure what they're talking about, just line up the letters in the words. So it says what percent. So what percent means we don't know what P is. What percent? That's what that's saying. What percent? I don't know. Of light will pass through 10 panes. So here they're telling us that we have 10 panes. And remember, 10 panes is talking about the variable n. So they're saying n equals 10. So just because panes does not mean P. Panes actually means n. So n is 10. So all you're doing is you're subbing in 10 for n, and you're using a calculator. You're literally plugging and chugging in. What you should get is 34.867%. So you're just plugging in 10 for n. Part B, what percent of light will pass through 25 panes? Okay, I'm going to say stop. Go ahead and try this problem. So this one is literally the same idea as part A, except now you're plugging in 25. So we're going to go ahead and do 100 times 0.9 to the 25th. Plug it in your calculator. And you should get 7.178%. Done. So again, even the word problem's not bad because they give you the equation. So even if you look at example 3, you don't know what they're talking about, doesn't matter. They've given you the equation. Line up what the variables mean. So it says can be used to find the number of milligrams D of a certain drug that is in a patient's bloodstream H hours after the drug has been administered. So D is the amount of the drug and it's in their bloodstream. H means hours after the drug is given. So just line up what they're talking about. And then go ahead and figure out what I'm solving for. It says, so after 1 hour. So 1 hour is talking about H. They're telling you H is 1. So you're going to go to your equation and you're going to plug in 1. Again, the problem is not hard because they've given you the equation. You don't have to write it. And when you get it, you should get 2.22 milligrams. Done. All right, go ahead and do part B. So part B is the same idea. We're going to go ahead and plug 9 now instead of 1 into your calculator, and you should get 0.201 about milligrams. Done. Okay. We are completely skipping this problem here on page 2. And then we're going to look a little bit at 6.4. We're actually going to skip example 2 for 6.4, and we're just going to do the word problems here. Okay, so we're going to be skipping a lot in this unit, so make sure you're kind of following along with what I cross off. So this next one, again, because we've already briefly talked about this, actually, this was a skill that we did in Unit 0. We're going to be solving simple log equations. So how do we solve simple log equations? When you are stuck in log form, you're going to change it to exponential. We already learned how to change things into exponential. So as long as you're very quick at that, you're fine. So we're stuck in log form. I don't know what that is. So I'm going to turn it to exponential. And again, there's always going to be 3 different parts. So we've got the 3 you're going to have to move. You have the 4x minus 7. And then you have the 2. You need to know where all 3 of those numbers go. So this is going to end up being 3 to the 2nd power equals 4x minus 7. So we were stuck in log form. We moved to exponential, and then you solve. 3 squared is 9. And then I'm going to add 7 to both sides. That's 16. And I'm going to divide by 4. X is 4. Done. Okay, take a look at part B. Oh, I don't know what that is. Turn it into exponential form. So the base x, exponent 2 equals 64. Oh, that's a lot easier. If I square root both sides, x is plus minus 8. If we take a look at part C, same thing, it's a natural log. We're stuck. Remember, it's a tiny e as the base. You're going to say e to the 11th equals e to the x, and you're going to go ahead and solve that. That's going to give you x is 11. Done. All right, I'm going to say go ahead and stop. I'd like you to try this one. All right, welcome back. 3 to the x power is 81. So that's going to be x is 4. Or if you want, you can get them to be the same base. Doesn't matter if you have this step or not. But either way, oops, I don't know why I threw an x in there. 81 is the same thing as 3 to the 4th, so x is 4. Again, that middle step is kind of optional because a lot of people just know 3 to the 4th is 81. They don't need to show that line of work. We are going to skip this one for now. We're going to get to it later and learn how to solve this one. So right now, cross that one off. We're going to go ahead and take a look at F. So same thing, looks like it might be a little bit harder because we have an exponential, but you're still going to turn it into exponential form because I'm stuck in log form. So 2 to the 4th equals x squared minus 2. Because again, you have 3 parts here, and doesn't matter what colors I use, but that x squared minus 2 needs to stay together. So 2 to the 4th, you can figure that out. That is 16. It's a quadratic. So there's a couple ways you could solve this one. I'm going to go ahead and add 2. That gives me 18 equals x squared. Then I'm going to square root both sides. So x is going to be plus minus square root 18. And then if I solve that, that's 9 times 2. So x is really plus minus 3 square root 2. Done. I'm going to go ahead and say stop. I'm going to have you try one more. All right, let's take a look. So for this one, same thing. You're going to go ahead and convert it. I'm going to change colors so it just doesn't get messed up with my other one. So 3 squared equals x squared plus 5x plus 3, which is 9. It's quadratic, so I'm going to move the 9 over and set it equal to 0. So 3 minus 9 is negative 6. Then I'm going to go ahead and factor it. That's going to be x plus 6 times x minus 1. So my 2 values for x are negative 6 and positive 1. Done. So when you have that x squared, you can factor it. That's one easy way to go ahead and do it. Let's go ahead and do last problem. I'm going to do with you. This one's a little bit different because the negative, so I want to do this one with you. Again, I'm stuck, so I'm going to go ahead and move it into exponential form. Okay, now I'm noticing x is in the exponent, but that's okay because notice I can get them to be the same base using what we talked about on page 1 of your notes. 16 is the same thing as saying 4 squared. Okay, once again, just like I talked about on page 1, you have the same bases. And when you have the same bases, you can set your exponents equal to each other. So this is just a throwback to page 1. Divide both, oops, I lost my negative sign. Divide both sides by 2, and x is going to be -4 here. So again, even though they start with logs, you're turning them into exponentials to solve, okay? That's it for the lesson. We're going to do more practice in class.